Hello everyone, this is Mrs. Crawford again. If you're watching this video, it means you were either absent the day we did this lesson, or you chose to do the video version of this lesson rather than the live version. Awesome, if that works for you, that's great. Do realize that this is going to be through Edpuzzle this time, which means you can't fast forward, and it does keep track of whether you're actually on the screen or if you go off to watch a YouTube video or some other thing. So be aware that that's kind of keeping track of it. The reason we've got that on there, if you're watching this as a video, this is replacing the lesson we would do live normally, which means you still need to be paying attention. You shouldn't have music in. You shouldn't be doing other stuff. This is your lesson for the day. So make sure you're fully paying attention to it, keeping track of it, getting the most you can out of it. This time we're tackling the next set of triangle congruences. Today we're doing two of them. SAS stands for side, angle, side, kind of like SSS was side, side, side. HL is going to be a special one that we'll talk about during the second part, and it stands for hypotenuse, leg. That one's not used as frequently. Really, the big one you're going to want to remember is SAS. That's the big one. So let's get started on that. So first of all, definition you're going to need, we're going to use the phrase included angle a lot. What I mean by that is really just the angle that's between two sides. So if you see my little triangle we've got going on here, the included angle is the one between these two pencils. So these would be my sides, angle in the middle, or included. Okay, so make sure you get that definition down. Here's all the stuff you got to fill in for SAS, stands for side, angle, side. This time, if we have two sides and the included angle, or the angle between of one triangle, and we know it's congruent to two sides and an angle of another triangle, the whole thing is equal. So if we just know a side, an angle, and a side, everything has to be congruent. That means the third side has to be the same, and every angle has to be the same once we've proven it. So in our picture, it would look something like this. We might know that AB and ED are congruent. That would be our first side. And we might know that AC and DF are congruent. Now, the thing you really have to be careful of with this, which I want you guys to pay attention and make note of, is it has to be the angle between. So I cannot pick angle C and angle F. That won't work. If I'm going to do these two sets of lines, it has to be here and here, because it goes side, angle, side, side, angle, side. So it's got to be the one between. It's super, super important that you pick that. If you do the one after it, it no longer proves that it's congruent. I know that sounds really picky, but if you pick C and F, it doesn't work. It's not side, angle, side anymore. Okay, so let's take a look at our first example. Remember, we always start off with our given, so let's make sure that that gets written in. Today we're doing a lot more where you have to fill in the blank. Starting to do a little gradual release there. So make sure we fill that in and state that it's given. Hopefully the easiest reason out of all of them. Do check your picture as well. Make sure it's accurate. Make sure it tells you what it's got. AE congruent to DE. Got here and here, so that one's checked off. And then we have EB and EC. Boom, checked off. Okay? So if I'm looking at SAS as my way that I'm proving things today, the sides are already done. I don't even have to do anything else with any more sides, but I do need to do something with the angle between them. So let's figure out where the heck that is anyway. If I'm looking at this as my top triangle, so let's highlight this bad boy. So if I'm looking at that one, which angle is between the two sides that have been picked? We have a side here and a side here. The angle that's between them is right here. So I'm just going to mark that for right now. And we'll take a look at the bottom one, do the same thing. We've got tick marks here, tick marks here. The angle between it is right here. So I know I've got to prove that that one is congruent. So let's first of all name it. We've got angle AEB. Remember, the E has to be in the middle. And it's hopefully going to be congruent to DEC. And I'm even matching my tick marks appropriately. So DEC. Okay. Now, why are they congruent? Hopefully, you're starting to get a good visual reminder of this. If you see this X, this diagonal angles, these kissing angles, these bow tie angles, whatever the heck it is you use to remember, please remember that these are an example of vertical angles. That should be something you look for literally every single time you do a proof. I'm not kidding. There are so many vertical angles, it's ridiculous. So please start looking for that and reflexive property right away, because you know you're going to be able to use it somewhere. That proves that those two angles are congruent. That's the last piece we needed for SAS. So that means that the two triangles are indeed congruent. Make sure you use the appropriate reason. Because we did two sides in an angle, our reason is SAS. It's not SSS all the time. It's not all corresponding, blah, blah, blah. This time it's SAS because we've proven it using that system. All right, this guy is going to be a tricky one. We're dealing with a new symbol here. I know it's kind of fuzzy. Hopefully you can see it better on yours. If you don't remember what that means, write it down. That symbol really looks like that. And it means that the two lines are parallel. That does not mean they are congruent. I'm going to say that again. Just because two lines are parallel does not mean they are congruent. So please don't just assume that. So let's go ahead and repeat what we've got in our statements and our given. So we've got that BC is congruent to DA. We could mark that in the picture, so let's go ahead and take care of that. BC, DA. Boom. Marked. Done. We also know that BC is parallel to AD. Can't really mark that in the picture with congruent symbols, but remember, parallel lines, we put those little arrows on them. So I'm going to put a little arrow on BC and a little arrow, poorly drawn arrow, but an arrow on AD. Okay, so both of my givens are now taken care of. They're in the picture. Awesome. Today we know we're focusing on SAS. So really all I've got so far is a side. Well, that kind of sucks, but at least I've got something. So let's look for an easy thing to see here. What is one of those things that we told you guys to always look for in the picture that's hopefully an obvious giveaway? For me, what I always see is reflexive pieces. So remember, here's my triangle 1, here's my triangle 2. They're overlapping right there, which automatically means that that side length has to be congruent. So if I mark that in my second statement, that'll be AC congruent to AC. I'm actually going to mark that with a double tick mark. I know it's not really matching with somebody, but it kind of helps me have a little visual so that I see that this is a side length that's being used in both triangles. If you want to put it there, you can. It kind of helps me personally. Make sure to put that it's reflexive property as our reason. Okay, so we now have both of our sides taken care of. Hopefully that was an easy one to catch. Even if you mess up everything else, at least get the reflexive properties, guys. I mean, hopefully that's a gimme at this point because we've used it every day. Now comes the tricky part. These angles, I think, are the toughest things to find. Sides are usually a little bit easier. Angles are where we get a little bit tricky. Now, they tell us that we've got some parallel lines in here. When they give you parallel lines, start looking for some of those angle pair types that we talked about when we did this transversal shape. Oh yeah, hey, this thing that we used a while back, it's actually going to come back and be used again. Look at that. So we talked about a lot of different types back then. We talked about corresponding angles. For example, here and here, those would be corresponding angles. We talked about alternate interior angles. That was another pair of congruent. So I'm going to write over here. No, not yet. So get rid of that. So that's alternate interior. We also talked about alternate exterior, like that. And we talked about vertical angles, which we've talked about before, that look like that. So those are the only options for things that are congruent to each other. You can do vertical, corresponding, handwriting's getting a little bit crazy, alternate interior, and alternate exterior. Those are your only options for things that are congruent. I don't really care about things that are supplementary because that doesn't really help me. So linear and same side interior, not really good options. Doesn't really help me too much. So I'm actually going to highlight, kind of like we did here. I'm going to try and get this sort of shape in my picture. So let's extend our parallel lines, kind of like we did back then, huh? Kind of funny how the things we did in previous units still come back to be used in current units. So what's the only line that is used in both triangles that's cutting through those blue lines? Well, this one doesn't really get used by both triangles. It's really only triangle 1. This one is only in triangle 2, but this one, the one I used for my reflexive piece, is right down the middle and gets used by both triangles, which is awesome. That's what I want. So let's start looking for that middle angle. We said it had to be between the two sides. We've got tick mark here, double tick mark here. The angle between them would be right here. So let's put a tentative angle arch right there. Let's make it purple actually so we can see it a little bit better. All right, in triangle number 2, we also had a tick mark here, tick mark here. Well, which angle is between these two sides? Right here. Okay, so I know I have to use those two angles. They're the only ones that are in both triangles and on this blue transversal shape. And they're the ones between the two sides, but why the heck are they congruent? Let's start by writing it out. B, C, A is over here. I know I kind of covered it up. Is congruent to D, A, C. Now, why? Why are they congruent? What type are they? If we go back to our blue transversal over here, it would be like this picture. They're between the two parallel lines. They're on opposite sides. One's on the left, one's on the right. What type is that? Hopefully in your head, you're thinking one or both of these words. They are alternate interior angles. And that reason alone, that name, is enough to prove that they're congruent because alternate interior angles have to be congruent to each other. So when you get those parallel lines, start looking for those angle types. One of those 4 is what it has to be. We've now proven our angle. Boom, that's done. That means I can put my prove statement here. Triangle ABC is indeed congruent to triangle CAD. And again, we did it by SAS, or SAS, for our reason. All right, last section we're going to tackle now is this HL section. What's tricky about this one is it's only for right triangles. I'll say that again, it is only for right triangles. The reason is because only right triangles have a hypotenuse and a leg. Those names only go with right triangles. Think Pythagorean theorem, right? The hypotenuse, the hypotenuse, or whatever you remembered from middle school. If you forgot, the hypotenuse is the one across from the 90 degree. From 90 degrees, and it's always the longest side. So those are 2 ways to help remember that. So in our picture, we've got hypotenuse as being congruent. Leg just means one of the other sides, so it could be like this and like that. Okay, so pause there, get your stuff written down. Last example we're going to tackle through. Make sure your given gets copied down here. I'm kind of running low on time, so I'm just going to have you copy it yourself. In the picture, it tells us ST is congruent to SR, so that's good. And SQ is perpendicular to TR. That means I know it's a right triangle. I've got a hypotenuse. The last thing I need is a leg, because hypotenuse, done. That's this piece and this piece, because it's across from the 90. I've got a reflexive piece right there in the middle. Awesome, I can use that. So SQ is congruent to SQ by reflexive property. I've got both the pieces, so now I can put this here by HL.